Okay, so we're gonna start off by talking about the visual representation that we just did on the board, and I wanna share with you this one. So let's take a look at this quantity x plus 3 quantity squared. If I was gonna take x plus 3 and square it, what would I end up with? Nick, yeah, what do you got for me, dude? I'd have an x squared plus a 6x plus a 9. So what this represents right here, this is a perfect square trinomial. PST, a perfect square trinomial. The reason it is because if I were to draw the picture, I would have an x squared here. I would take 1, 2, I'd have, this would be my 3x. This would be my other 3x. 1, 2, and then 3. This is what we just did on the board. And then I would have 9 pieces left over to exactly do what? To complete the entire square. Alright, so this is what's called a perfect square trinomial, and this is what we're going to use in order to complete the square and solve quadratics. So to help us learn how to complete the square, we have to get really good at solving square roots. So let's practice a little bit. If I gave you 4x squared equals 36, what would you do first in order to solve for x? Yeah, Nick, what do you got, buddy? You could subtract 36 from both sides. Yes, indeed. That would give us 4x squared minus 36 is equal to 0. We can take out a 4. That will leave us with what? I think it's 9, right? Equals 0. So we'd have the 0 product property. So either 4 equals 0 or x squared minus 9 equals 0. Well, 4 never equals 0, so that can't be true. But this could be what? Yeah, this is the difference of two squares, right? This is x plus 3 times x minus 3 equals 0. Or, solving the 0 product property again, I'd get x equals negative 3 or x equals positive 3. And now that's not the normal way, or I mean, that's not the way most people would do it. I'm guessing that most people would do this instead. I'm thinking that most people would divide by 4 on both sides and get this, x squared equals 9. So therefore x equals plus or minus 3, which is exactly what we have there. Either way is completely fine. I love the fact that you actually move the 36 to the other side and then pull out the difference of two squares. I think that's really neat that you see that. Either way is completely fine. Correct. Yeah, we'd have to do something else. Let's try B. Let me give you another example. Let's do 3x squared minus 5 equals 25. How do you want to go about doing this one? Yeah. Minus 25 on both sides. We could do that. 3x squared. What would that be? Minus 30 equals 0. What can we do now? We could take out a 3. That'll give us x squared minus what? 10 is equal to 0. Now what would we do? Divide by 3? No. We already took out a 3, yeah. Add 10 to both sides. Okay. X squared is equal to 10. So x is equal to plus or minus the square root of 10. Now, why the plus or minus in this case? Yeah, whenever you square a number, you get a positive, right? So we're gonna go with what the book has for us as plus or minus square roots of 10. Okay. All right. Let's do C. Let's add 10 to both sides. Let's do 7x squared is equal to 35. Then what? Divide by 7. Then what? X squared would be what? 5. So therefore x would be what? Good. And I want you to leave your answer as plus or minus the square root of 5. Alright, you're allowed to do that. Last one for this box, let's do 2x squared plus 9 is equal to 13. Alright, Hank, what would we do first? 2x squared would be, what's 13 minus 9? 4, then what? Yep. So x squared would be what? 2, so x would have to be plus or minus the square root of 2. Alright, are we good at solving square roots? Yeah, we're good at solving square roots. We can leave our answer with a square root in it. That's totally acceptable and totally fine. Alright, so we're going to start by taking a look at a plus b and squaring it. If I took a plus b and square it, what would it be? What would I get? I'd get a squared. You can just yell it out. What would it be? Plus 2ab. Yeah, don't forget that. Plus a b squared. Alright, so that's what we would get. We would get a squared plus 2ab plus b squared. So this is a known fact when we expand a binomial that we are squaring. Everybody in the room knows that? So the question then becomes, how can we take, let me get there with that. How can we take x squared plus bx? What is the process that we need to do in order to change something that's in the form of x squared plus bx into a perfect square trinomial? And I'm going to start by showing you the visual of what we did before. So does everyone agree that x squared plus bx can be represented like this? If I have this x and x, and then I have this right here, if I call this length b, so then this part, the area of this one will be x squared, and the area of this one would be bx. Do you guys agree with that? Have I done anything crazy or ordinary out of the blue here? You guys good with that? Okay, so if I'm only working with these two tiles, so to speak, right, the x squared and the bx term, watch what I'm going to do here now, right? I'm going to erase this, and I'm going to cut this one in half, and I'm going to redraw this in purple like this. I'm going to do it here. So this is going to be an x by an x, and then I'm going to have a piece here, and then I'm going to have a piece here. So I cut it in half and I moved it. So the question I have for you now is, what is the length of this side right here? If it was b and I cut it in half, what would the length of that be now? Yeah, this would be b over 2. Do you guys agree with that? So that means that this one over here would also be a b over 2. You guys cool with that part? So now the bigger question is, look, there's a little piece that's remaining here, right? It's this little tiny piece over here. So the question now is, what is that piece? What's the length of that? Yeah, Nick. Yeah, look, this is the length is b over 2. The width is b over 2, so this becomes b over 2 squared. Does everybody see that? Okay, now let's just write everything down that I have here in this picture. If I write everything down represented in this picture, I would have this. I would have an x squared. I would have one of these things would be a b over 2 by x. So this is a b over 2 by x. That would be this one here. The length is b over 2. The width is x. I would have another one of those, a b over 2 by x. That'd be this one up top, right? And then I would have a b over 2 squared. Do you guys see that? Well, this looks really, really familiar, doesn't it? Doesn't this look exactly like doesn't this look exactly like a squared plus, oh look, a 2 times a b over 2x, there's a 2ab, plus a b squared. Do you guys see it? Do you guys see the structure of that? Yeah, exactly. So look, I have a b squared x and another b squared x, so I have two b squared x's. Do you guys see that? Do you see the structure? So this is exactly what this is saying up here, right? So therefore, the whole scheme of this, in the entire big scheme of things, here's what we're trying to say. We're trying to say that x squared plus bx plus b over 2 squared is the same thing as x plus b over 2 quantity squared. That's what we're trying to get at. All right? That's what we're trying to show. And this is the geometric proof for. Okay. Let's solve it. Does anyone see the perfect square trinomial? Yeah, Nick, where do you see it? No, not the answer. Does anyone see the perfect square trinomial? I want you to actually see it. Do you see it? No. I'm asking for the perfect square trinomial. Does anybody see it? Okay, what is a perfect square trinomial? It is this right here. It is this right there. That's what a perfect. Yeah. Yeah. Okay. Does anybody see it? Yes. This whole piece, x squared plus 4x plus 4, that is a perfect square trinomial because it can be written in the form of x plus 2 squared. You see it? Okay, that's a hard concept to get. Is now equal to 25. Right? So. You can. You end up in a different spot. You end up with the same answer, but it's a longer route to get there. Okay, square root, square root. X plus 2 equals plus or minus 5. So x equals negative 2 plus or minus 5. So x equals -7, or 3. So yes, of course you can factor, okay? But some of these you can't factor nicely, right? This one you happen to. I'm trying, the main goal for this one is hoping that you guys recognize this, the highlighted part. That's the main goal, because that's something that you're not used to. So do you recognize that that can be a perfect square trinomial? That's what I'm trying to get at. Okay? Let me show you another example. This one was easy because you could just subtract 4 and then factor it. It won't always turn out that way. I'll give you a couple of examples in a minute. Let's do this one though. X squared minus 14x plus 49 is equal to 25. Does anybody see it? What do you see?
X minus 7.
Good. This becomes x minus 7 squared is equal to 25. Look how fast we got to that, right? So therefore, x minus 7 is equal to plus or minus 5. Therefore, x is equal to 7 plus or minus 5. So your two answers have to be 2 or 12. Okay, if I gave you x squared minus 10x, how could we then create a perfect square trinomial? What would we have to do? We would have to take half of b, which would be what? -5, and square that, what would it be? So we would add 25 to this to create what? To create x minus 5 squared. That's what I want. That's what I want you to get good at, is seeing that. Okay, do you guys cool with that? All right. Let's try another one. Let's do b. What if I gave you this? How about x squared plus 6x? How could you create the perfect square trinomial? Plus what? So plus 9, what would that then do for you? X plus 3 squared. Very good. Okay, let's make it a little more challenging for you. Let's give you this one. Let's give you x squared plus 5x. What makes this more challenging? It's odd. Does it work the same way? Of course it works the same way. So what number would you add? Okay, I want you to keep it as a fraction. Keep it as a fraction. 25 over 4. Very good. Because I would take 5 halves. I would take half of b and I would square it. That's where the 25 over 4 comes from. Good. What does that do for you now? What does that create? Yeah, x plus 5 over 2 squared. Very good. Right? How about this one? Let's do x squared plus 7x. How do you create the perfect square trinomial? What would you do? Add what number? You would add 49 over 4, and what would that do for you? Very good. X plus 7 over 2. All right, let's do 3x squared minus 12x plus 6 equals 0. We're actually going to solve this by completing the square. If you can factor out a greatest common factor, you should do it every time. So what can we factor out first? 3. That will leave us with what? Minus 4x plus 2 equals 0. Now, notice that can't be factored nicely, right? Because the factors of 2 are 2 and 1. I can't create a -4 out of that. So we wouldn't factor. We could always use quadratic formula, but we haven't gotten to that yet technically in the book. So what can we do? We're going to create a perfect square trinomial. Yeah. Yeah, very good. We're going to move the 2 to the other side and make some space. So x squared minus 4x. And I always leave some space here to equal -2. And whatever I add to one side, so whatever number goes here, I'm going to have to add to the other side over there. So notice the space that I'm leaving for each spot, right?
Doesn't that 3 that you took out matter?
No, I just divided 3 on both sides. 0 divided by 3 is still 3. I mean, it's still 0. Sorry. That was silly. So what number goes there? That's my question. Half of -4 is -2. Squared would be a positive 4. So a 4 goes here, and a 4 goes there. Now, what does that do for you? How does that help you? X minus 2 squared equals what? 2. All right, now we're back in square root land, right? So we just take the square root of both sides, and we get x minus 2 is equal to plus or minus the square root of 2. Therefore, x must be 2 plus or minus the square root of 2, and that's how I want you to leave your answers, because that's how it is presented to you in the book. We're going to do another one in a second, so let's call this A. All right, solve by completing the square. What should we do first? Yeah. Let's do 2x squared. Let's do minus 2x. If I do 3 minus 9, what do I get? Minus 6 equals 0. Good. Can I factor anything out? I sure can. Let's factor 2 out. So that'll give me x squared minus x minus 3 equals 0. Notice you can't factor that. It doesn't factor nicely anyways, right? So we're going to complete the square. And we're going to keep everything in fraction form. So the first thing I'm going to do is I'm going to go x squared minus x, and I'm going to leave myself some room here, equals, I'm going to move the constant to the other side, and whatever I add to one side, I better add to the other side in order to keep my equations balanced. Question becomes, what is it? What's the value that creates the perfect square trinomial on the left-hand side? 1/4. I love that you guys are seeing this. Good. Half of 1 is 1/2. We square that and we get 1/4. Good. 1/4 goes here. 1/4 goes there. Awesome. What does that do for you? That gives you x minus 1/2 squared equals, let's see here, 13/4. I love it. Very good. Adding two fractions, keeping it as a fraction. Don't change it to a decimal. Okay, therefore x minus 1/2 is equal to plus or minus the square root of 13/4. Can I simplify anything on the right hand side? Yes, very good. So x minus 1/2 could be equal to plus or minus the square root of 13/2, because the square root of 4 is 2, right? So therefore your answer should be read like this: 1/2 plus or minus rad 13/2. I just moved the 1/2 to the other side, and that'd be it. 0. Okay, I want you to solve by completing the square. Notice you cannot factor that thing nicely, but I want you to leave your answer in square root form. Okay, Hank, what'd you get, dude? 6. No, that's not the right answer. Yeah, Jake, what'd you get, dude?
Plus or minus rad.
Okay, so walk me through it from here. What would it be?
Okay, so you have to put negative 12/2 squared, so you get 36.
36 goes here.
And there.
36 goes there. Yes, very good.
Then you can factor that to perfect square, so it's x minus 6 squared equals 29.
29. Good. Then what?
Take the square root of both sides, and then x minus 6 equals plus or minus rad 29.
Mm-hmm.
And x equals 6 plus or minus rad 29.
Yes. Who got 6 plus or minus square root of 29? Let the record show that everybody's hand is up in the room.